All right, we are going to talk about finding the surface area of cones. Okay, so to find the surface area of a cone, you need the lateral area, which is like the sides of the cone. So like here's an example of the cone, right? It's in my hand, and so there's the sides of the cone, and I can unravel it. It looks like that, right? And then there's also the circle bottom that fits underneath. So if I've got a cone, let's draw one. Okay, so there's my cone. If I unravel it, then my net cone, it looks something like this. Let's just trace it. Okay. So this is the lateral area. We'll use LA for short. And then we've got the circle bottom. Okay, so the area of the circle bottom is is pi r squared, and the area of this area here is for r pi l, and we'll be talking about, I'll do a derivation on the next page on how to do that. So let's pretend I got an example. Here's an example where we know the slant height. Okay, so this L here, this stands for the slant height, which is along from the point to the edge. So let's define that. So L is the slant height. Okay, and the slant height goes from the top of the cone to the edge of the cone. Okay, and so here's an example. We've got the slant height is 14, and we know the radius is 8. So using this formula, the surface area is equal to r pi l plus pi r squared. We're going to get 8 times pi times 14 plus pi times 8 squared. Okay, so then we get, what is 8 times 14? We get 112 pi plus 64 pi. And so 112 plus 64 is going to give me 176. Okay, and if you multiply 176 times pi, we get 552.9. Let's write that down. So that's approximately 552.9 units squared. Okay. Now how did we come up with this formula? So I'm going to show you on the next page here. So I've got this cone, right? And I've unraveled it, and we get this. So this is really makes up a circle, doesn't it? So we need this fraction of the circle to be to tell us how much of this circle we use for the slant height. So for the slant height, we've got so the area of the big circle is equal to pi r squared, right? And for this big circle, the radius is this pink line, and this pink line is the slant height, right? So the area of this big circle is equal to pi times L squared. Okay. Okay. So because this is the radius of the big circle, and so pi r squared. So now we need to figure out the ratio. So the ratio is equal to this part right here divided by, so this blue line divided by the yellow line is going to give us the ratio. So our ratio is going to be, this blue line here is 2 pi r, and that's because this circle here that's attached to, this is the circle on the bottom of here. This is the circle on the bottom here. We know that from here to the edge here is r because of this right here. So this here gives us the area of the circle, and the circumference goes from here to here is 2 pi r. Okay, and the whole circle is 2 pi l. Okay, so if I simplify this ratio, we're going to end up with r over l. So this slant height area, the lateral area here is equal to the ratio, which is r over l times pi l squared. And the L is going to cancel out on the bottom and the top, and then you end up with the lateral area equals R times pi times L. Okay? And that's how we get the lateral area being R pi L. So, and then once again we have the area of the circle. So the base, the area of the base equals pi r squared. So, and so the total surface area equals the lateral area plus the area of the base, which is so r pi l plus pi r squared. Okay, so this is the lateral area plus the circle base. Okay, that might have been a little confusing. You may want to re-watch this video to get this part here. This is an explanation on where the formula comes from. You won't need to derive the formula on the test. You'll just need to know how to use the formula. Okay, let's do one more example just so we can practice this. Okay. So, let's make up some numbers. Okay, in this example, I'm going to give you the height of this is going to be 4 meters, and the radius is equal to 3 meters. Now the formula for this, the surface area is pi RL plus pi r squared, right? That's what we just determined on the previous page. Well, we don't know the slant height, do we? Because that's this part right here, but we could figure it out using Pythagorean theorem. So using Pythagorean theorem, we end up with 3 squared plus 4 squared is going to give me my hypotenuse squared, is a slanted L. So 3 squared is 9, and 4 squared is 16. 9 plus 16 is 25. So the square root of 25 is going to be 5. Okay, so we're going to use L to be 5, which is the slant height, and R is going to be 3. So let's do this. So pi times the radius is 3. The slant height we just said is 5 plus pi, and our radius is 3. Okay, so we simplify this a little further. 3 times 5 is 15. So 15 pi plus 9 pi, and 9 plus 15 is going to give me 24 pi. And if I want to find an approximation, I can go on my calculator and I can say, okay, what is 24 pi? And then we get 75.4 meters squared. Okay, I hope that works. If you have trouble, watch this over a few times, and I hope that helps.